Hey, what's up, guys? So let's solve this 2096 step-by-step directions from binary tree node to other. This problem I can solve this in the context, although it's a little bit long, but we can separate into piece by piece, and we can solve it. So you have a root of binary tree, and each node is uniquely assigned value 1 to n, and then you have some start value and destination value, dest value, and you need to find the shortest path from S and T, but there is a step-by-step direction. So you see the shortest path step-by-step directions, and with the unweighted binary tree. So the which you should come out with is the BFS, right? Because BFS can find the shortest path in the unweighted graph. So this is almost I think the standard, the optimal one to find the unweighted graph and the shortest path. Okay, and you need to do is the step by. You need to find a step by step. Okay, so let's maybe see an example. For example, this 3, 1, 5, 2, 6, 4. You should go up, and right, and left. Okay, so let's maybe first is okay. So imagine that I want to solve this problem, right? So first is in a tree form, right? So I want to use a BFS. So one simple idea is that I first do the tree traversal, right? I first tree traversal, and I can build a graph. So first step I can do is I can build a graph by using an adjacent list, right? So maybe 3, right? So 3 need to map to 1, and 1 map to 5 and 3. This is the adjacent list. So I have a dictionary, and 5 map to 1 and 2, and 2 map to 6 and 4 and 5, and 6 map to only 2, and 4 map to 2. Right. So this is the unweighted. This is a graph, right? So this is the adjacent list. Okay, now once I build this graph, I can use the BFS. I start from the starting points. This is 0, 1, 2, 3, and once I find the answer, then I can trace back to find its parents. Okay, so there are two. Okay, yeah, this is the step. Okay, so to outline the step, first need to tree traversal, and build a graph. Yeah, build a graph. Maybe let's do this separate to step 3 steps. So first tree traversal, because after the final step, I need to know which one is a left, which one is a right, right? So I should build a dictionary. So first I do the tree traversal and I have a dictionary, which given a node value, I should give it the I separate into this kind of form, right? So there are 3 of them. This is the left child. If there is a left child, so I should say the node left value, and this is a node right value, and this is a parents. So this parents is okay. So this parents is the tree parents, not the graph parents. So tree parents. Yeah, tree parents. So node parents. Okay, if no value left or right do not exist, I use 0. Okay, I use 0. Okay, so this is the first step, tree traversal. This is important because I need to know which one is which one. So for example, this dictionary will tell me that if D of, let's say, 3, 3 do not have left and do not have right, right? So I should put 0, 0, and the parent is 1. Okay. So for each node, I have this, right? So this is what I need to remember. Okay, and the second step, I build a graph. Okay, so build a graph and the tree traversal can do the same time. Okay, and the third one, so this is you can use the in order, post order, whatever. And the 3 is you use BFS. Okay, once you use a BFS, you will finally get another parent dictionary. So remember, this parent, this is the tree parent. This parent is a graph parents. Okay, so get graph parents, and then you can combine 1 and 3 and get the answer. Okay, maybe hard to understand. Let's do it step by step. Okay, for first, I can first dictionary parents, parent root value. So this parent is the parents that 1 has a parent 5, 3 has a parent 1, 6 has a parent 2, 4 has parent 2. By the way, 5 do not have parents, right? So I initialize. So due to the convenience, if roots do not have parents, I use 0. Okay, I do in order. If roots in order left, if in order right, right? So if root left, if root has a left, then I need initialize it to be left value, just like what I said. So the first position I use left, and the parent root level value should be root value, right? Because that means this left has a parent root, and I build a. If there's no roots left, no left child, I initialize at 0, and if right, I do the same thing, right? I append the root right, and otherwise I append 0. So once I do this, once I run in order, I will get the I will initialize the first 2 coordinates. I will initialize the first 2 coordinates, and also I got a parents dictionary. Okay, so now I just need to concatenate it, right? So it's very simple. I can concatenate it now. Okay, so now I can also create a graph, right? Because these two are actually the same, right? Once you build a graph, each node only connected into left or right or parents, right? So once you have this, then you can build a graph. Okay, so graph initialize a dictionary for I in keys. If I in parents, that means the parents is non-empty. Then graph I denote to D of I plus parent I, right? So this is the build graph. Okay, so now you can print a graph. Maybe let's do it step by step and print a graph so you understand what I'm saying. So this graph looks like 0, 0, 1, 3, because 3 do not have any left and right, right? So initialize to be 0, and 1 is a 0. 1 has a left 3, and no right is 0. 5 is a parents. For 5, it has 1, 2, and parents. No parent 0. For 6, you get 0, 0, 2. For 4, you get 0, 0, 2. For 2, you get 6, 4, 5, right? 6, 4, 5. 4 is 0, 0, 2. Yeah. So you see this, the first dictionary, this guy is a. So this guy, this graph, basically is the flattened version of this tree. Okay, so this you have graph. Now, once you get a graph, the rest is trivial, right? You just run a BFS. Okay, so once you get a graph, the thing you need to do is just run a BFS. Okay, so you just run a BFS on the graph starting value and the destined value. And I think everyone knows about BFS, right? So so let me just quickly say it. So this is the Q and the parents. So this parents is a graph parents. It's not the tree parents. Okay, and the append S and the visit S to be true, right? So this is a simple BFS. The only difference is that if I is non-zero, you do this, right? Because I use 0 to say that there is no value, just for the convenience. And if I equals to t, that means you already find the answer, right? So you should return the parents. These parents is a key. We need to use these parents to get our answer. Okay. So after this, let me just print a parent so that you guys understand what I'm talking about. So this parent is become 1, 3, 5, 1, 2, 5, 6, 2. Okay, so let me just copy, and so that you can see the answer comes from this dictionary. So you get the 1, 3, 5, 1, 2, 5, 6, 2, right? So what is the path? 6, 2, 5, 1, 3, right? So you go to the last one. 6 go to 2, 2 go to 5, 5 go to 1, 1 go to 3, right? So 6, 2, 5, 1, 3. Okay, so once you have this dictionary, then you are happy to go, right? You're happy to go because you already find the shortest path. Okay. So what is the rest? The rest is to print out the step by step, right? So you can initialize the answer to be empty. Okay, so now you need to start from here. So you have two parents, right? One is the graph parents. So 6 mapped to 2, right? And in the original 6 is a child of 2. So in this case, if their parents are the same, their parents are the same, then you need to check that this is a left or right child. So I need to check that where 6 is the left child of 2 or 6 is a right child of 2. So if the D parent's decimation value 0, this means that this means this coordinate, the first coordinate. Yeah, the first coordinate. Okay. So this is check, right? If it's the left value, then I add L. If it's the right value, I add R. If you don't, if there's a no condition, if the parents they are different, means that your results, your previous roots, you do not go this way, you go another way. So that means you should go up. You should go up, right? For example, in our dictionary, 1 map to 3. Okay, 1 map to 3. So you see 1 map to 3, right? 1 map to 3. So go this way. It's reverse. So I should go up. I should go up. So if their parents are the same, there is a L right. If not, there is a up. And while the destination value do not is start value, that means you haven't arrived at the destination. Then you just keep running this. And finally, so each step, that's the value will become its parents. Okay, so this parent is a graph parent. Finally, return all the answers and the reverse. Okay, so in this case, you get the answer, right? Because I think this problem is simple. Once you arrive this, then this problem will be almost trivial. Okay, and I will post this code in the below the video. So hope you guys subscribe to my channel. Yeah, you can submit. I think this is still doable. Okay, although it's probably not best, right? But maybe there's I think you can combine some of maybe the build a graph when you do the root traversal, right? But I think this is simple. Okay, so see you guys next videos.